Welcome back to Young Tutor. Today we'll be taking up another set of number systems just like we did last time. Last time we learned about integers, but if you remember, I hinted about this video which was rational numbers. Rational numbers are not difficult, but they are quite a complex topic as they involve so many numbers. At this point, there are so many rational numbers that the number of integers are infinitely like the number of integers times infinity still won't give you the answer for how many rational numbers are there. There are a lot of rational numbers. So because of this, um, so now let's take some examples of integers first. If you remember, like I'll take the same examples as that we took last time, which were -3, 2, -5, and 10. These were some common examples that we took last video where we understood about integers. This time these are also rational numbers as rational numbers consist of integers. So all these four numbers are also a part of rational numbers, but to be exact, rational numbers are the fractions. I believe you've known about fractions for a long time, as we've learned that from a long time ago. So fractions are is nothing but should be written in a P by Q form, where Q is not equal to 0 because no number is divisible by 2, so Q is not equal to 0. And P by Q is just variables. It can be either A by B, where B is not equal to 0, or anything else. It is just two variables that we have taken. So now what can be examples for a rational number? Some examples for rational number are -7 by 10. As you can see, it's a negative fraction. A 7 by 10 is also a rational number, as it's again a fraction. Rational numbers are nothing but the numbers that consist of fractions and negative versions of fractions. Fractions and negative fractions. That is practically what rational numbers are. As we also know that any number, like for example, or any integer, if we go for more specificity, if this is an integer, to make it into a rational number, all we can do is divided by 1, as any number divided by 1 is the same number. So over here you can see that the two numbers are in P by Q form, that is P is equal to -10 and Q is equal to 1, which means these two numbers are in P by Q form, where Q, which is 1, is not equal to 0. This is the simplest understanding of what rational numbers are. So now let's come over to addition of rational numbers. Now let's see how can we actually add these rational numbers. It's the same way how we add two fractions. So for example, let's take the same rational number we had taken earlier, that is -7 by 10, and let's add it with -10. If you remember earlier, we took these two examples itself, as one being an integer and one being a rational number. So if we to equate this problem, all we can do is we can apply the same things we have learned in integers, but and also the same things we have learned in fractions. So we have learned in fractions that to add two different fractions, we need to first get the denominator to be the same number. Here we can see that by making this into a rational number, we can see that the denominators are not the same or are not equal to each other. Therefore, we can write -10 by 1 as -7 plus 10 plus -100 by 10, as we are just multiplying the same -10 by 1 into 10. This is equal to this itself, so we are not actually changing the equation. Now we can see that as the denominators are the same, we can actually add this equation. But as there is minus sign in both, if we remember, now all we can do is hide the bottom part. So now if you remember, you can see that both of these are nothing but integers from earlier. And we learned how to add integers, which is very simple. Just take the minus sign together if there's only a minus sign and add the normal units. 7 plus 100 is 107, and then put the denominator, which is 10. This is your very simple answer. This is just one example on how to add. For the second example, we'll be taking 1 by 7 plus minus 1 by 8. It looks like a simple equation, but as you can see, it's 7 and 8 in the denominator, which doesn't make it like fractions. Therefore, all we have to do is multiply, as they both are co-primes, because the only common factor between them is 1. So they are co-primes, causing them to, all we can do is multiply 7 times 8 and 8 times 7. So this will become 8 by 56 plus minus 7 by 56. You can see that the signs are opposite. As both the numbers, that is, if we cover the bottom, we can see the integers on the top, or the numerators are not on the same sign, do not have the same sign, as 8 is positive while 7 is negative. So all we have to do is the same thing we've learnt earlier, which is 8 minus 7, and then take the bigger number sign, as in this case is plus, so we'll leave it like that, and 8 minus 7, which is 1, so it will be 1 by 56. We have learnt this already, but because it's just similar to that of integers and also fractions. Now let's start up with subtraction. Subtraction with rational numbers is very similar to that of addition, so I won't be going that much in detail, and we'll be doing only one example. Because I have some other stuff to tell after a while, so we'll be doing only one example. We'll be taking minus 7 by 10 minus of minus 10. So it's again very simple, that we have learned earlier, as minus of minus becomes plus, so it will be minus 7 by 10 minus, it become plus, so it will be 100 by 10. This is different from what we have done earlier, as we have done minus 10 earlier. This time we are doing minus of minus, which became plus. So minus 7, so all we have to do again is the same thing we have learnt already. Plus sign, as 100 is bigger than 7, and we have to subtract 100 minus 7. 100 minus 7 is 93. So it will be 93 by 10. 93 by 10. This is the answer. This subtraction is very simple. It's very similar to addition. All we are doing is replacing plus with a minus sign, and in case there's a minus of minus, we're making it into a plus. That's all subtraction is in rational numbers. It's very similar to that of integers. For the last topic for today, we'll be taking up reciprocalizing or multiplicative inverse of rational numbers, which we didn't actually do in integers, as integers would turn into rational numbers when they reciprocaled. But reciprocal is nothing but making the numerator the denominator and denominator the numerator. And in case there's a minus sign, all we are doing is take the denominator's minus sign to the numerator. So for example, let's take the number, first example we'll be taking, will be the same number we have been taking since the last, minus 7 by 10. For all we can do to reciprocalize this number, it's not exactly equal to. So this number, when we reciprocalize it, it will become minus 10 by 7. You see how the numbers actually interchange the digits between the top and the bottom. That's all reciprocalizing means. It's not a complex topic, and there's no actual way to represent it. So reciprocal is just a very simple top covering topic. It's not too difficult to understand. But a second example that I'll be taking for reciprocalizing will be 1 by 7, as we have taken earlier for the addition, the second example for addition, 1 by 7. If you see here, this will turn into 7 by 1, but we've learnt in fractions that any integer which has 1 in the, like any fraction which has 1 in the denominator automatically converts into a whole number, because 1 can divide any number, as I've said earlier. So 1 by 7 when it's multiplicative inverse, like 1 by 7's multiplicative inverse is 7 itself. For today's homework, we'll be taking some simple numbers. I want you to add these numbers. For addition, we will be taking -8 plus 1 by 17. Again, I already told you how to add these numbers, so we won't be going in detail with that. But if you can see, the number is prime, so all you have to do is multiply multiply both the numbers till you get the LCM. Okay, and then we'll be taking the second one, which will be subtraction, which is as similar to addition. We'll be taking minus 1 by 20 minus of minus so we'll be taking minus 1 by 20 minus of minus 8 by 5. And for the multiplicative inverse, your homework will be to reciprocalize two numbers. The first will be 8 by 7 and the second will be 1 by 9. These are all very simple. You can go ahead and try it on your own. Some multiplication will be required, and comment the answers down below. And as always, please like, share your videos, and subscribe to the channel if you liked the videos that I upload. And thank you for watching. Meet you next time with the multiplication and division of rational numbers. Thank you for watching.